Okay, good afternoon, everyone. Welcome to this homework discussion session. Today we're going to talk about the sorting and searching homework, which is gonna due tomorrow, 11:45 p.m. Okay, so in general, this homework is not that long. There are three problems, and the first one is really just help you to warm up. And I think the um, the code and algorithms are already given there. What you should really do is you can just like run the code and trying to get some ideas about different sorting and searching algorithms. Okay, so okay, let's start with the first one. As I mentioned just now, the first one is just a warming up problem. So you guys can take a look at the discussion note on the left side of the uh, of the screen. Okay, note 11. Okay, so basically the first problem just asks you to compare the performance of different sorting and searching algorithms. I think if you watch the video and look at the slides, you should already be very like clear about the straight insertion, like merge sort, these two algorithms. And there is also another. I think MATLAB it has a function called sort, but probably this function is doing the sorting using a different algorithms. So basically, this function is just asking you to run the code for the three different algorithms and trying to get some conclusion about the efficiency and performance. Okay, so and similarly, there are two searching algorithms like linear search and then binary search. Both of them are actually in the slides. So if you have any basic questions about those searching algorithms, you can either search online or you can take a look at the slides back. Okay, and basically the way we compare the performance or efficiency of those algorithms is by taking a look at the time it needs to finish doing the sorting and searching job. Okay, so if you look at the example code on page 1 or page 2, you see that there is a TIC and TOC for like every algorithm. So basically, this TIC is basically telling the MATLAB to start recording the time, and TOC is basically when we ask MATLAB to stop the watch. Okay, so by this you should be able to get a elapsed time for doing sorting and searching in each algorithm for comparison. Okay, and uh, remember, like one important thing is you need to get some conclusion, especially when the amount of numbers you need to sort or search increase. Okay, so that's done by increase the the numbers. Okay, so you see for both sorting and searching code, you have a for loop, right? So the numbers n start from 1 to 20 for the sorting algorithm and 1 to 50 for the searching algorithms. So basically, as the n increase, the number in this unsorted array or sorted array for searching will actually be increased. So the dimension is going to increase, and you should be able to see the whether one algorithm is superior to some other ones very clearly as the amount of numbers increase. So you should be able to get some conclusion there. And let's see. Uh, I am not quite sure. I think you need to. Okay, I think you need to briefly comment the performance of different like sorting and searching algorithms in your published file. So what I really recommend you guys to do is to put these two codes in your script, okay, and do the comment after you run the script. Okay, you can basically have a discussion about like which algorithm gives you the best result when the amount of numbers to be sought or searching is small, and when it increase, how is this trend gonna change? Okay, so you're gonna briefly comment about the performance for both parts. Okay, so I think question 1 is actually fairly straightforward because you actually don't need to do any coding. Okay, and for um, for the second question, okay, this is basically focusing on sorting. Okay, so this question is asking you to write a function to implement what they call the counting sort algorithm in MATLAB, which is an alternative to the sorting algorithms presented in the class. Okay, so basically the idea is once you're giving an unsorted array for every element, you basically count the number of elements that are smaller than this one, okay, and put this number in a separate array, and then based on this number, you will be able to see, okay, in the final sorted array, which location should this number be, and in that case, we'll be able to do the sorting in another way, okay. So I think first, very importantly, what you need to do is read the algorithm and the example carefully, especially the example. I found this example actually to be fairly clearly for you to understand what's going on in these algorithms. And for example, if you look at the table on page 2, so the unsorted elements actually are on the first row, and you see 52, 10, 1, 25, blah blah blah. And then for the second row, is basically it actually counts how many numbers are actually smaller, how many numbers in the original array is actually smaller than this corresponding element. So if we take a look at the third element, 1, because it is actually the smallest number in this array. So actually that means zero number of elements are smaller than it, right? So you put this count 0. But the reason why we need to increase by 1 in the index row is that you cannot put a number in the location 0, right? You should put it in the first place, second place, third place. And that's why we basically increase everything in the count row by 1. And that's how we get this index row, okay? And after you get this index row, basically you just put the number correspond to index 1 in the first place, put the number correspond to index 2 in the second place, and so on and so forth. Okay, so finally you get this 1, 2, 3, 3, 8, 10, something like that. And one thing to be really careful about is the case when you have one entry that is repeated more than once, right? So in this case, I think the number 3 occurred twice, right? So basically you see that this number 3, the counts, both of these are 2, okay? And you will be able to see 2 numbers with index 3. So what you should do in your code is you need to automatically increase one of the index of these 2 by 1 so that 1, 3 will be put into the 4th place. Okay, so that will avoid some index issues there. Okay, so after you're done with a code, what I recommend you to do is quickly check your code with some very simple example first. I give you an example like 3, 1, 3, 2, 4, 5. See if you can get 1, 2, 3, 3, 4, 5. Okay, using your code. And I think probably the find function could be used there to see, okay, how many numbers in the array are actually smaller than the one that you are currently looking for. Okay, so but this is not, you're not necessarily use find function, but I just find this might be useful. Okay, and then you should test your function using the unsorted array using the example given on page 3. Okay, so that's basically the part for question 2. Okay, and for question 3, okay, so question 3 probably is the trickiest problem in this assignment, but it is not that hard, I think. Okay, so basically this one is doing searching problem, right? So, and they want you to implement the interpolation search in MATLAB. Okay, so this is some sort of a variation of the binary search you guys learned in class. So the difference is that in the binary search, okay, so you basically cut the searching domain into two, but the index you choose to do the cut is just like you choose the middle point index, right? So for example, you have 10 points, you will probably like cut it around 5, right? So but this might not be that efficient, especially when the array, especially when the numbers in this array is not like equally distributed. Okay, so the way to solve this problem is to use this called interpolation search, and the idea is actually shown in the notes. So here's the thing. First, you want to read the algorithm in the searching in this assignment. But if you find hard to understand that, I point you guys to an additional example. You see a link there. And that one probably, I think in that one there is a interpolation search example, and you guys can take a look and see if it will help you better understand what's going on in this algorithm. Okay, and but let me like simply like explain what's going on in this algorithm. So basically, the algorithm finds the index to break the array using a linear interpolation. Okay, so for example, I think I write this in the note. You guys can take a look. If I1 is the index of the first element, A1, and IN is the index of the last element in this array, AN. Okay, so there are basically n numbers in the search space. Okay, so let's say if the key is x, so basically you want to find this x in this array. Okay, so what they do to find this index for the cutting is by doing this to find this I middle. Okay, and this I middle is actually done by doing this kind of linear interpolation. Okay, they assume a model between the number, between the value and the index. Okay, so they assume they follow some sort of linear relationship. But of course, this might not be the truth. Okay, so this is basically just a guess. Okay, so and the equation or the algorithm you need to use is actually already in this node. Okay, you can see I middle equals to I1 plus IN minus I1 divided by AN minus A1 times the difference between X and A1. So remember that I something is the index, A something is the real value. Okay, so in that case, you should be able to get a better guess of where you should actually cut this array. Okay, so and once you find this I middle, okay, and of course this I middle might not be a integer. Okay, you might be able to see, okay, this I middle is some sort of like a 3.5, 4.5 something, and in that way, what you can do is you can probably looking for the floor. So that means you can do it like if I find I middle equals to 3.5, I do treat the index as 3 instead. I will actually write it down here. I will say if I middle is not an integer, you can find the index by floor I middle. Okay, so you can definitely do like probably sail I middle as well, but I kind of prefer to use this one, floor I middle. Okay, and then what we do is we check whether this I middle, I should say whether this A middle, okay, I middle, okay, equals to X. That means let's say we find the index, okay, in this original array, and what we really want to see is whether the number correspond to that index is actually X. Okay, but there is a great chance that it is not X, right? Because the first thing is the actually number in this array may not follow a linear relationship, right, between the value and the index. So if you find, okay, this A middle is not X, what you do is you compare whether this number is greater than X or smaller than X. Okay, and in that way, you should be able to locate a smaller search space for you to continue, right? So if you find, okay, this A middle is smaller than X, that means the X is actually between A middle to AN, right? And in that case, you should be able to actually put like limit the search space to a smaller zone, and within that you do this linear interpolation again by changing the A1 to the first element in this new search space. Okay, so remember, every time when you cut the original search space into two, and once you realize that the X should be in one of the domain, in that case, the index for the first element and the index for the first element or last element and the value for the first element and last element in the smaller searching space is going to change, right? So you have basically changed the search space. So you should be really careful when you do this in your code, okay? So basically, once you get a new search space, you need to increase the number of petitions, right? Because you actually search a new petition, okay, and running the interpolation again using the equations above, but you need to be careful about the index as I mentioned above, okay. And then finally, what you need to do is to remember to, so after once you're done with this searching, okay, again, I still recommend you guys to check this really quickly using some very simple example. So for example, if you have this 1, 2, 3, 3, 4, 5, and see if you can quickly find that number 4, okay? And once you figure out, okay, so my algorithms are good, in that case, what you do is to follow the assignment, okay? So they want to basically compare the number of petitions examined by both method. One method is this interpolation search, and the other one is just this binary search discussed in class. I think the code for binary search one is already given in your assignment package, so you can directly call that. And remember, you need to change the B search one a little bit so that it will just output the total petitions. And you should also probably change the output for your I search, okay, so that every time it would just like output the total petitions it goes through, okay. And basically, if you look at the example code on page 4, so you have this kind of for loop, right? So the k index starts from 1 to 10, so that means for the first iteration you only have 10 numbers, and for the second one you have 20 numbers, and all the way to 100 numbers. And as the number increase, okay, if you want to find a key, that will make it actually a little bit harder, okay, for you because actually you need to go through more more numbers, okay. So in that case, you should be able to see, okay, which of these two algorithms give you a better searching result, okay. So that means in that case, for example, if once you have a large, for example, if your k equals to 10 and you have 100 numbers, and if the petitions you examined by research is much larger than the petitions you examined by iSearch, that essentially means that, okay, the efficiency, the iSearch algorithms is more efficient, and so in that way we will kind of prefer that one. Okay, so you should probably be able to come up with some conclusion about the efficiency. And remember, you need to include in your published file a plot comparing the number of petitions. Okay, and that plot should be the number of petitions against the corresponding value of k. Okay, so you have k from 1 to 10, and you basically compare, okay, how many petitions I did for each of the k using two algorithms. Okay, and you should be able to see some kind of trend in your figure and come up with conclusion. Okay, so I think this is basically what I want to talk about in this assignment. It's actually not a very long assignment, and I hope you guys will be able to finish this assignment really soon. And And I think I will take the next couple of minutes to answer several questions if you guys have. Uh, and I think that's the end of the discussion for today.